Hello everyone, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to explore a fascinating topic, that is one which is shaping the very backbone for the future internet, in the subject Internet of Things. If you have ever wondered why we need IPv6, how does it works, and why it is so crucial for the Internet of Devices or the Internet of Things and the modern networking, then stick with me. By this end of video, you will understand what is IPv6 and also you will understand why IPv6 is just an upgraded version of IPv4, but it has revolutionized the internet addressing. Let's start with a big question. Why do we even need IPv6? Yes, the answer lies in the limitations, that is IPv4 exhaustion. When you think of IPv4, it offers not only 4.3 billion addresses, it offers 4.3 billion addresses which are unique. So that sounds like a lot, right? But think about the rapid increase in smartphones, laptops, IoT devices, sensors, and even smart home gadgets that all require Internet of Address. So clearly we can say 4.3 billion addresses are just not enough anymore. Yes. So, and that's where the IPv6 comes in. So IPv6, when you take, it offers a mind-blowing addresses of 2 power 128 addresses. To put that into perspective, that's enough addresses to give every grain of earth, that every grain on sand of this earth will have enough unique IP address. And still, we will be having a plenty left over. The another reason is NAT. So that is network address translation. So this tried to extend IPv4 by letting multiple devices share one public IP, but it was only a temporary solution. It is just a temporary fix. NAT adds complexity and even breaks the idea of true end-to-end connectivity. So IPv6 solves this very clearly. Now that we know why IPv6 is needed, let's break down what an IPv6 address looks like. So when you all know, IPv6 addresses are 128 bits long, which is divided into 8 groups of 16 bits hexadecimal value, each separated by colon. Okay, each separated by colons. For example, look at this. The IPv6 address is of this kind, which is 2001 0db8 colon 8583 colon 0000 colon 0000 colon 882e colon 0370 colon 7334. So this address can be simplified using compression rules. So we have two rules to compress this address format. So the first rule is the leading zeros can be eliminated. That is, remove leading zeros. The next rule is, the second rule is, replace consecutive blocks of zeros with double colon. So let's see. The same IPv6 address can be written as 2001 colon db8, because the 0 has to be delimited. db8 8583. Then here you can see a group of zeros. So this can be eliminated by double colon 882e 370 7334. So the same address, now it looks pretty neat, right? So it is much shorter and the easier to read version. Now let's see the IPv6 address type. So when you look into this, there are three address types that are supported by IPv6. The first one is called unicast, second one is multicast, third one is anycast. What is meant by unicast? So If an unicast is there, it means that it identifies a single or one-to-one communication. That is a unique sender and a unique identifier. Unique sender with a unique identifier. This is unicast. Okay. The next one is multicast. So here in multicast, it delivers packets to multiple interfaces in a group. So one to many. So one sender, you will have many receivers. Then comes anycast. So in anycast, it routes to the nearest reachable interface in a group, optimizing the service delivery. So this is called anycast. So first it will reach the nearest interface, or it will deliver the packet to the nearest address. Then from there it will be optimized to different services. So this is called anycast. And here in IPv6 it doesn't support the broadcast. So IPv6 replaces IPv4's broadcast with multicast itself. And also it has a special addressing like loopback and link local. What is loopback? It just loopback addresses or nothing back. It tests, the system tests itself whether it is connected to the network or not. So this is specified by : 1, that is 127 bits of zeros followed by 1.